attempted to estimate the proportion of Miramichi smolts that are being predated by presumably striped bass in the Miramichi River. Just give you a bit of an idea as to where we are. So this is eastern Canada and a little bit of Maine there in the US. The Atlantic Salmon Federation, we have our hands in a few projects in rivers across eastern North America. The river that takes up the majority of our resources is the Miramichi River, which you can see in the map here. And one of the tools that we tend to employ the most is acoustic telemetry. And as we've heard from a number of people, especially today, that you use acoustic telemetry to look at migration timing, behavior, and survival. We do this primarily for smolts. We have started some kelp work in the last few years, but most of it's with smolts. So if we zoom into the Miramichi River system, we've been tagging and tracking smolts here since 2003. Oh, the legend's really messed up. Anyway. Basically, what we have here is the release locations, which should be yellow triangles in the legend, but aren't. It's a number sign. But you can see those in both rivers, the north and southwest, and then the colored points just represent where we have more receiver arrays throughout the Miramichi River. With respect to survival, we're estimating survival only to 3 key gates. There's a head of tide location, which are those orange circles that you see kind of right there and there for both rivers. And then we're estimating survival to the outer bay, which are the purple dots. And then we operate a Strait of Belle Isle line as well, which is that tiny piece of land or strait between Newfoundland and Labrador. And that's about 25 kilometers wide. So we're estimating survival to those 3 locations. And basically the results of those survival estimates look like this. We've modeled them in a very similar fashion to what Stephen had presented yesterday, just using that Bayesian state space implementation of a CJS model. And so what we have here is each year, I've just staggered the box plots on top of each other, and it helps kind of, you can see how many fish are basically losing from one location to the next a little bit easier, I think. So you've got release, or survival from release to the head of tide in the red, to the outer bay in green, and then when the Strait of Belle Isle came online in 2007, survival to those locations as well. And you'll notice that in the northwest Miramichi, unfortunately we didn't tag or track any smolts between 2009 and 12. But the one thing that you will notice is that survival to the outer bay location for those smolts had been kind of relatively consistent. You could say the same thing for 2013 to 16. However, something obviously happened here. There was a lot more fish in recent years being lost between the head of tide and the outer bay location. So one of the things that we hypothesized was, well, maybe it's due to this increasing abundance of striped bass in the Miramichi River system. And for those of you that aren't familiar with them, I just thought I'd give you a bit of background on striped bass. They're a coastal fish. You'll usually find them within kind of a stone's throw of the beach, generally speaking. You'll find them in estuaries, lower portions of rivers. That's typically where you're going to find them. Now, the population that we're specifically interested in is what's known as the Southern Gulf of St. Lawrence population. They're genetically distinct and geographically more or less isolated from other populations of striped bass. And like all striped bass, sorry, I forgot to mention that red cloud is about the distribution of them. But they're aggregate spawners. So that means they move together to spawn. And the only known place that this happens is, I'm kind of expecting a drum roll here, is a relatively small portion of the northwest Miramichi River near the head of tide. So essentially, every single spawning adult in this population is moving to this head of tide area in and about there. So it's about 6 or 7 river kilometers, maybe a kilometer wide, if that. Now, because of that feature, the Department of Fisheries and Oceans has been moving into the Miramichi River to try and estimate the abundance of striped bass. And they've been doing this for several years anyway. And that's what we're looking at in this figure is the abundance of spawners in this population. So you'll see that by the late 1990s, the population was on the verge of extinction. There was only about 2,000 or 3,000 individuals spawning in the entire population. In short, they basically just, the government put a moratorium on all recreational commercial fisheries for the species, and from a management perspective and from the striped bass perspective was a huge success. You can see kind of around 2006-07, just this exponential growth in the population. You fast forward to 2015, and Dave was nice enough to point out they have 2016 estimates as of several days ago, which is 318,000 with huge confidence limits, as you can see. Anyways, a lot of fish, and they're all moving into this 6x1 stretch of the head-of-tide area. So you could imagine that's a lot of, I think the average size is about 45 centimeters, but they get quite a bit larger, and they're pretty aggressive if anybody's ever fished for them here. Anyway, a lot of fish, big area, or small area rather. So the primary concern was due to the fact that when the bass are moving into the river, it more or less coincides with the time that the smolt are leaving the rivers. And because of this concern, there was a collaborative project that started between the ASF, the Department of Fisheries and Oceans, as well as the Quebec provincial government to kind of look at the spatial and temporal overlap between the two species. They wanted to quantify some things there. And so the main reason we were involved is that we'd already been tagging and tracking smolts in the river system, and the infrastructure was essentially already there. So for us to be able to look at the movement of both species, the only thing that needed to happen was someone needed to go out and catch some bass, put some acoustic transmitters in them, and then all the movement for both species is being logged on the same receiver units in the river. So that's what DFO and MFFP did. They went out and they tagged 120 bass. The project started back in 2013 and was to go until just this past year in 2016, so 4 years. And then just to go back and show you again where we have receivers in the river system, what this is really, I think, kind of pointing to is the scale of the movement that we're capable of measuring. So in other words, we're talking about the resolution of data. And so, typically at the end of every season, as anybody who's used acoustic telemetry stuff here knows, you go out, you collect all your receivers, you download all the data, and a good first place to start is plotting the individual movement of all your transmitters. You kind of want to look for typical, atypical patterns. And so typical smolt movement usually looks like this. You've got the date and the time of the detection on the x-axis. I've marked that outer bay location as the 0 kilometer, and then the further up the y-axis you are, the further up the river you are. The different colored points, which don't really turn out too well here, just denote to different locations in the river, whether it's the northwest branch, the southwest branch, the main stem, so on and so forth. And then at the top, you've just got the transmitter number, and being a bit of a birder before this, I have this really bad habit of abbreviating all the genus and species names to the two first letters, so SASA just being short for Salmo salar. And so that's very typical smolt movement. I'm sure it probably doesn't come as a lot of a surprise to many of you. It's just unidirectional and going from the river to the ocean pretty quickly. You do the same thing for striped bass. Again, all the same things are true for the XY axis. The only thing that's different is the abbreviated genus and species name, MOSA just being short for Maroon saxatilis, striped bass. But you'll see it's a very different movement pattern. There's staging in different sections of the river for different periods of time. There's really quick up-downstream movements and changes to direction. You see this kind of plateau towards the end here. This is both the time and location of where that spawning event occurred, at least in 2015. So not every movement pattern is typical. You end up getting some very atypical movement patterns. So this was a smolt that I tagged in the southwest Miramichi River, and you have it coming down the southwest. I know they call me the samosa hunter back. Anyway, so it's coming down the southwest Miramichi into the main stem, turns around, goes up the other branch quite a ways, bounces back and forth. It's hanging out on the bass spawning grounds at the same time that the bass are there. You could kind of just draw the kind of quick assumption, well, okay, this looks like a pretty likely predation event. Up until the point where it looks like this is where the predator basically pooped it out. Yeah, exactly, right? So that's a very subjective way of doing it, and I thought to myself, well, if we have these very typical ways, or typical patterns and atypical patterns, could we model this, put this on a probabilistic scale so we can take that subjectivity out of the equation? Because, obviously the problem with subjectivity is what you would call a predation event, I might call just a more variation in a smolt or something along those lines. So we're going to try and take out that subjectivity. So before I do that, I have to measure a bunch of different features about these movement patterns for all of the bass and all of the smolt in these 4 years. So I measure things like the number of reversals, how many kilometers upstream did it swim, so from a smolt's perspective, the wrong way, how many days on the bass spawning grounds, yada, yada, yada. A whole bunch of different variables that we measure that can hopefully differentiate between typical smolt movement and typical bass movement. And so then we can start to model this problem. And the type of modeling that we wanted to employ, not to go too far into the weeds, is what you would refer to as a supervised learning algorithm as opposed to unsupervised. The big difference there being that supervised learning algorithms, you're supplying them with labeled data essentially. So what I want to do is say, here's a whole bunch of smolts, this is how smolts behave, here's a whole bunch of bass, this is how bass behave, here's an unknown transmitter, you tell me what you think it is on a probabilistic scale, is essentially what it's doing. So we basically, I developed I need to develop this training data set now. With the bass, it's really simple. I can just show it all of the transmitters that went into bass and just assume that, this is representative of true bass movement. The smolts, we can't do that. Some of them may have, in fact, be the movement of predators. So the big assumption here that I'm making is that if I have any smolts being detected at the Strait of Belle Isle receiver array, which is some 800 kilometers from the mouth of the Miramichi River, well beyond the range of striped bass, and just the time alone, it would probably pass any tag if they ever did make it there. I'm going to assume that if I have a smolt hitting on that receiver, that its in-river movement is representative of true smolt movement. So that's my big assumption. That's my training data set. I train the models, and then I basically just say, okay, here's all the transmitters we put into smolts. You tell me what you think all of these smolts are on a scale of probability, smolt by smolt by smolt. And so what that basically looks like is represented in this histogram. We got 4 panels, one for each year, and then just the counts of the transmitters that I've just put in 10 percentile bins. And so what you're ultimately looking for here is you want to see 2 modes. You want to see a whole bunch of fish at 0 and a whole bunch of fish at 1. Anything that's straying too far from that, I guess I should say that these are what the model would call a bass, and these are what the model would call smolts. Anything straying too far from that is the model saying, well, I'm not really certain what this is. I'm kind of on the fence. You could have that model spit out just a binary classification scheme and say, heads or tails, 1 or 0, bass or smolt, in which case it would draw that line at 50%. So that's essentially like saying 50.1%, I'm going to call you a bass, 49.9%, I'm now going to call you a smolt. So when I talk about these proportions, I'll show you the proportion just under that binary classification scheme, but I also want to take some of that uncertainty, because it does seem like, there's quite a few fish kind of moving towards that 50% mark. I want to take some of that uncertainty into account. And so I have this scaled estimate, and I just really quickly want to go through an example what I mean by it. It'll probably be second nature for a lot of you. But basically what I have is just a table of 3 smolts. There's the transmitters. They're all Northwest Miramichi smolts. And this is the probability that you're a bass. So the first one, there's a 0.4%. The second one, 99.95, which is the one in the plot here. It's saying there's a 99.95% chance that you're exhibiting bass-like movement behavior, which I'm interpreting as a predation event. And then the third is 15%. So it's still going to call you a smolt, but with a little less certainty. And so under the binary classification scheme, you would say, well, it looks like one of my 3 smolts had been predated, or 33%. If you just sum all these probabilities up and divide by the number of transmitters, you get a proportion that takes that uncertainty into account. So essentially what's happening is this little bit of uncertainty is bumping this from 33 up to 38%. So that's the scaled estimate. And then we'll go through the final results here. And I'll just walk us all through the first row of information so that everybody's on the same page. So Northwest Miramichi, in 2013, we tagged 40 fish, but we only heard from 36 of them again. So the proportions are reflective of the number here, the 36. I can't say anything about the 4 fish I have 0 data for. So under the binary classification scheme, you've got 16.7% of those fish being predated. The scaled estimate looks like 26.6% of the fish have been predated. And then here, this is just survival, the point estimate for survival from release to the head of tide in Outer Bay. So that just kind of gives you an idea of how many fish we're losing in that area. And then the point estimate for the abundance of striped bass as well. I won't talk through all of these numbers. I'll kind of let you just look at them and take away from it what you feel is interesting, and feel free to beat me up and question me on this if you need to. But you will see, the Southwest Miramichi, as I think you'd expect, there's a lot more variation, and that's probably just due to the timing of when the bass are moving in as opposed to when the smolts are moving out. There's not quite as much of a spatial overlap for that stock. In saying that, we've presented the results to the Department of Fisheries and Oceans in the last several months. And I didn't want to go too far down the rabbit hole here, but they did a very similar study, and they found much, much lower numbers of predation than we found, orders of magnitude lower. It's nice to see that they're actually going to be taking the results of this experiment into consideration when they're updating their management scheme, I think for 2017. Recently, because of the higher abundance, they have been looking at, or they have opened up a small recreational fishery, but the retention period is quite small, so there's some ideas about maybe lengthening the retention period and possibly looking at maybe opening up a small First Nations commercial fishery, something along those lines. Long story short, it's nice to see that the effort that went into this is resulting in some management action. And then the last thing I want to say is that the whole goal of this exercise was to identify if a smolt had been consumed by a predator, and to do that in a very non-subjective way. If you do that, if you identify a particular smolt as being predated, then you're going to run into some problems, because what's going to happen here is, let's say you're trying to figure out the average time to gate X. If you have a predator taking one of those tags there and you identify it as a predator, you're in this situation where if you're looking at timing, you could just remove that individual, but then you're throwing a very valuable and costly sample size. If you're looking at modeling survival, then you're forced to make this subjective decision as to where you think that predation happened. And so if you want to avoid having to subjectively decide where, or removing very valuable samples from your data set, then we need more quantifiable ways of determining where. And I think that was actually one of the topics we had in the discussion before lunch, or at least it was going there anyway. I think really interestingly, the company that we get all of our acoustic telemetry data from, Vemco, which I think a lot of you have probably worked with, they're coming out with a predator tag for the first time this year, and basically, it gives you a slightly different transmission if the trigger has been tripped saying, I've actually been consumed by a predator. All the detections you hear from this point onward, you might want to disregard them or use them in a different manner anyway. So we're really excited to be using their product for the first time next year to see if we can find more quantifiable ways of determining where, not just if, smolts are being predated. So yeah, thank you, and I'd like to thank everybody that made this possible.